my colleague Dr. Sunita Nair, she's a sustainability expert, and we work with her with IIT Madras to do that. Yeah. So we are a flooring contracting company. Uh, this is our as a humanity, this is our target to limit the global temperature increase by 1.5 degree, and vis-a-vis 2019 we need to reduce 43% by 2030. Yeah. uh, a nice saying by Vincent is great things are done by a series of small things brought together. Because my understanding of reducing carbon footprint is also doing small changes in everything what we are doing. In terms of our flooring, it is right from concrete to steel to number of man hours, number of machine hours used. This is how we bisect in our work. Yeah. uh, a law by Mueller. I am sure there are a lot of experts here on sustainability, but it is if we just drive sustainability and it is not having a lifetime performance, then it doesn't make sense. So this should have the impact of all the three facets, which is economic impact, of course, because I personally believe if we are developing something, if you are innovating something, if you're not saving the money, then we are not innovating in a scientific way. Yeah. So economic impact has to be there. Obviously environment impact, because the topic is sustainability, and also social impact. Yeah. This is how we believe a company is based on three fundamental things. Technical know-how. We have designed a software along with IIT Madras and IIT Palakkad, which can explain later on sustainability part. And we are a flooring company, and we are using this to make a sustainable solutions based on experimental data. So when it comes to concrete, earlier gentleman was talking about, we are developing mixes specifically for flooring with slag and fly ash. We are also part of LC2 in IIT Madras, which is a low carbon initiative of IIT Madras. Uh, on sustainability or on strength, there are a lot of studies of using fly ash or using GGBS for concrete. Yeah. But when it comes to flooring concrete, the surface area to volume ratio is far different than the normal structures, and we need more of a workable concrete, because you compare a beam where you are putting a concrete with GGBS. After you cast that beam, if you vibrate, your job is done. But in flooring, after you pour, we keep on working for next 12 hours. So we also have to see the finishing effects of using GGBS or fly ash. Another thing we are developed with IIT Palakkad is, uh, I think all of you must have seen flooring. The flooring is generally cut at 4 meters across India. For white topping, it is cut at 1.5 meters. We are trying to develop a formula or a chemistry with concrete that we can increase these joint distances. Increasing joint distances is better for maintenance. It is also better for using less machines in cutting the concrete. So this is how we are doing. So we are aiming at 60 to 70% reduction in joints. We started working on this activity 2 years back. We have got a further grant from government now to extend the research. I think by end of 26 we will come out with some formula which we can use in any Indian concrete, which will help us to reduce the number of joints in the concrete, whether it is floor or road. This is a bit of what we do with our design. Particularly flooring design is controlled in India by some product people or some specialized consultants. In COVID, we developed this software. What is the use of this software is, this software doesn't need any particular code, or it is not any particular product. It is a performance based software based on three codes, which is ACI, our ICI guideline, and TR34, which is the English code, and it is agnostic to fiber type. So we can use any product in designing a sustainable floor. Life cycle analysis, we do cradle to grave analysis for the projects what we are into. This is one case study I want to share. This is a project we are doing in India. This is one pour plan. The people who are aware about flooring, they will understand this language. So there were two areas in this particular project. One thickness was 250 kg with 8.75 kg of SFRC. and other area was 300 thick concrete with 14 kg of rebar reinforcement. Yeah, we work around with customer about application. We work around the use of the floor, and we developed and established the sub base patterns. This is how we changed it. Yeah, from 300 we went down to 200 all across. So in one area there was a saving of 50 of concrete. Other area there was a saving of 100 of concrete across the section. Steel percentage also we reduced substantially. Wherever there was SFRC we reduced by 60% steel fiber consumption. Where there was rebar, we reduced the consumption almost by 70%. Uh, this carbon and all these things, whatever I understand, the more benefit you get by using less and less materials. So we targeted the very point of reduction of the material. So we reduce concrete, thereby reducing cement. Uh, we reduce steel, thereby reducing the carbon needed for this. What we got is in concrete quantity we save 20%. In steel quantity we save 65%. In the control joint we save 90% of joints we saved. Uh, this is the saving in terms of carbon footprint. So we did a calculation with customer, and customer could get 42% carbon footprint saving. From the design, first the project was designed as a section design. So the thickness was designed for flexible strength and steel was designed for cross sectional area. We moved it to system design. So from elastic approach, we moved to design to the plastic approach. That is the design we change we did, and we gave carbon footprint saving of 42% to customer. This is about my case and my presentation. I am not sure whether it was too detailed or too short, but this is what I want to present, Asta.